Okay, hi guys. Welcome to my presentation. Today I'm going to talk about cycle 3. It is all about chapter 4, 5, 6, and 8. Alright, so let's start with chapter 4. Security technology. Well, the picture is an example of enterprise closed system. Well, in this example, the enterprise will probably want to connect it to the internet or finding partners, and the enterprise might want to provide network access to guests who visit. Also, if it offers wireless connection to people, there are possibility of offering wireless access to people too. Okay, so next one. And this is an example of enterprise extends beyond its own boundary. So what we see is there are many users and internet is there and business partners there. So it looked like it will be more difficult to maintain a safe or secured boundary. Next, common security threat. Okay, as we are aware of security problems or threat, modern enterprise networks are made up with many parts of different components. What I mean is that it is made by various things, so it will be hard or complicated to secure. We can't secure in easy way until we configure what is vulnerabilities, such as many difficult threat and different threat and from different entry or exit. And I would like to talk about attacks that spoof addresses. So normally our PC, when it sends an IP packet, we expect the source IP address to be its own IP address. Also, the MAC address in Ethernet is expected to be sender's own MAC address. In this picture, so left side here, so literally it looked like a attacker with cigar. So he sends packets with spoof source IP address like zoop, not its own. So our target corporate server, when it receives the packets, it will send return traffic to the spoof address, not the actual address. So what happened is that if the spoof address exists, someone unsuspecting host with that address will get the packet. Of course, someone will get a packet if they're in the same network. However, if the address doesn't exist, for sure the IP will be forwarded and drop out in the network, like somewhere else. So the thing is, an attacker can send spoof MAC address too, because literally it is adding false information to the forwarding tables. Okay, next, denial of service attackers. So let's think in a very easy way. So when we're trading something, clients start conversation which will be opening connections to exchange the stuff. Stuff will be the information in here. So the process is simple. User open a web to corporate site and open TCP. After that, some transaction will take place. If everything is in order, the servers will not be stressed and nothing critical things won't happen for sure. So now let's think the malicious user is using for the way to open the connection to the same corporate server. TCP connection with malicious will send the SYN flag to the server, but address, is it going to be real? No, it's not. Also, fake address is not involved in the TCP connection. So there won't be no ACK reply to complete this TCP three-way handshake as we learned. The incomplete connection will be staying in the server's table until it is going to be removed. So check the example. Okay, so never mind about the connection, it will be listed until full here on the TCP connection. So When bad guys are attacking on our system, what will happen? For sure, our system or everything will have crashed. We call that DOS attack. What is that? It's DOS attack. Denial of service. As the word says, it denies service to users or operators. DOS attacks can involve ICMP packets, a flood of UDP packets. So my favorite part is the DDoS. The best example would be there's a quite secondary road built in anticipation of dozens of vehicles passing by the way, like very busy road. What if one day thousands or tens of thousands of vehicles suddenly appear on the road? It will become more of parking lot than just an ID card, and eventually it will be impossible to maintain many PCs or car in my example, and attacking one particular website or source will call that DDoS. So next one, reflection and amplification attacks. Okay, this one, the attacker sends packets with spoof source to a target. Easy, right? And it forces the target to deal with spoof traffic, sending return traffic towards a non-existent source. So this is reflection attack. The host reflecting the traffic to target. What we call that is reflector. Easy. So the point is, we don't know what he sent. So it could be multiple reflectors by attacker, so that it can cause the target to get multiple traffic. And next one, man in the middle. Okay, so man in the middle attack is very simple and easy to understand. There will be one guy who's listening and getting all information from me, client, and other communicating. Well, it's server, but there must be another one. So if one host needs to send the data to another, it looks for the destination host in its ARP table. It looks a little bit complicated, but well, actually it is not really complicated. So number one, client send an ARP request and it flooded to all hosts, which means the attacker can get it and listen it in here. It's flooded in here, and well, the hacker is listening to it here. The attacker in number three, here. He wants a brief time and send the spoof ARP reply with MAC address, so it's time to attack. Or gathering information can be, not the actual destination. So imagine how terrible it is. Someone is getting or snatching or listening my information or what I'm doing in the middle. Oof. Next. Buffer overflow attacks. So when we're operating systems, applications do reading and writing data with buffers and temporary memory space. Buffers are very important in communication. So what we have to be careful is that sometimes buffers overflow, because incoming data can be stored in unexpected memory location if it is beyond its limitation. Well, so if hackers send large data than our device expected, overflowing will eventually happen. Next, malware. Everyone knows about Trojan horse, or not. Maybe in terms of network, it is hidden packaged way to attack. So, for example, I downloaded one file from a known blog because it looks fun, and I have no idea if there's Trojan software or not inside. So, what if it's silently installed in my PC with the thing that I downloaded from the unknown blog, and malware, and in my PC, and malware can do attacks in my local system or devices easily. Usually it is from downloading some things from unknown blog or cafe or in that, whatever. So, next. This is going to my fast part. A. So, A, authentication. Who is the user? Authorization. What is the user allowed to do? Accounting. What did the user do? So basically, we could authenticate users with password for devices, and authorization can be actively logged in. We're authorized for exact level privileges with correct password with high privilege level can be. And accounting, what did the user do, as I said. Okay, next. Chapter 5, Securing Network Devices. So the ultimate way to protect password in Cisco is not storing password in iOS devices. And we can use AAA too. So this picture shows an example of typical login security config router or switch. On the right side, config address support for login with username and password. It supports Telnet and SSH users. And on the left side, we see Telnet support config with password only. So, okay, this is an encryption and the service password encryption command. So in here, after we put show running config, we can see the original password confirm list, encrypted password instead of the clear text. So we learn with the number of encrypted password, and here we used level 7. So our service password encryption, this command can encrypt password, but no service password encryption. This doesn't immediately decrypt the password, surprisingly. This is how it works. Okay, so after we do no service password encryption, it still remain encrypted until we change the password. So it means it takes some time to get changed. So encryption is immediate, but decryption, we should wait. Okay, so this is Cisco iOS encoding password, which is password, it is type 9, so enable secret 9. So with the enable secret and enable secret 9, it means we use type 9 secret level, really high. Well, not really high, but it's just decent high. Okay, so next, implementing switch port security. Okay, now we see that every device requires the security for sure. Let's start with port security concept and configuration. So why port security is important? Because we know that every devices are connected with ports. It is based on the source MAC address of Ethernet frames that the device sent. So okay, so here, PC1 sends a frame in the picture with switch 1, F0/1 line, and switch 1 would examine PC1's MAC address and decide whether PC1 allows to send frames into this line. So port security has several flexible options, but it appears with the same concept. It has like similar concept in here. Okay, so next one. Let's check how to do port security configuration. The switch port security command enables port security, and it is all defaults. So switch port mode access, this is configuring the port as either an access or trunk port. And the final port, F0/4, it must be in here. This one, it has similar configuration, but this is configured as a trunk rather than access port. And when we look for the first interface, we see the switch port security MAC address. It defines a specific source MAC addresses, so the frame with source other than the number enters F0/1 line. The switch would normally perform MAC address, and it will be wanting to add the new source of MAC address to the table. On the second line, in the fast Ethernet 0/2, it is the same, but switch port security MAC addresses this is a switch to dynamically learn and add port security commands to the run config. It seems very complicated, but it is not. Okay, so DHCP snooping and ARP inspection. Okay, so DHCP snooping on switch, personally, I would say it is detecting and filtering DHCP messages, and switch DHCP messages could be detected, and this content would be filtered, should be filtered, So what I learned is all equipment in switches, routers, and L3 switches, and L4 switches can be checked up to L4 protocol. That was kind of interesting. So, okay. This is DHCP attack supplies good IP addresses, but wrong default gateway. Okay, so DHCP server created and attacker releases a useful IP address to PC. Also, the default gateway is 10.1.1.2. 1.1.1.2? Okay, this is attacker PC's address, not this one. So this is a wrong one. So now PC think, oh, I'm good to go, and it connects to the network whatever is sent by PC1. So what's going to happen? It will flow to the attacker's PC first. As we know, we call that man in the middle. Okay, next, DAI, the dynamic ARP inspection. Switch examines incoming ARP messages on untrusted ports to filter. And this feature is the typical sequence. PC1 want to send IP packet. Where's PC1? Here. Okay. Shooting this way. To router 2, excuse me, which is default router, so they can send ARP request with router 2. Router 2, where are you here? 172.16.2.0. And router 2 send back ARP reply. Listening router 2's MAC address. And at the bottom, 2 are both hosts here. It seems like 2 hosts are learning the other host's MAC address to message flow sending and receiving together. So in this cycle, I was concentrating on chapter 4 more than others because chapter 5, 6, and 8 was mostly experiment part with labs, and personally chapter 4 was more important and interesting. Thank you for listening.